Hello, this is Ira again. Today we're gonna go over valves 181001 and we will review knowledge 5. In this knowledge, we will learn a little bit about thermal binding, how to manually close an MOV. We will learn about the packing gland, backseat, and interlock. And that's all that we have for this section. So thermal binding. So what is thermal binding? Thermal binding is a differential thermal contraction. So it's generally associated with the gate valve that is closed while the system is hot and then is allowed to cool before we try to open up the valve. So this happens, when this happens, we're gonna have different cooling rates across the valve. So we have different materials across the valve. So we're gonna cool at a different rates because we have different types of materials in here. So what happens is that when we cool down for maintenance, this gate valve will internally cool at a different rates and the valve can jam against its back seat. And this is gonna be my back seat right here. So that's what it can happen, and we will all go over what a back seat is. But yeah, so this part. So here, this back seat is where I can jam, and this can cause me different problems because it can make the valve inoperable, and we don't want that. So we want to make sure that we can operate the valve. Right, that we can move it up and down with no issues. So now we have also the manually closing a motor operated valve, as we can see in this picture here. So the motor operated valve, so on this type of valve we don't want to apply excessive torque because several things can happen, right? If we apply excessive torque, meaning that if we close it like very hard, like we can damage the seat, we can break the hand wheel. The hand wheel, if we try to close it too much, we can break it. We can break the stem. We can damage the housing. So we don't want to do that, right? So those are the things that we will try to avoid while closing a motor operated valve. Okay, so now we're gonna go to the packing gland. There are two things that are gonna happen if the packing gland is too tight. The two things that we're gonna look at GFEs is that it's gonna increase the stroke time and it's gonna cause the stem to bind, meaning that the valve is gonna get stuck. So the packing gland is just this contact type sealing element. It's gonna be this contact type sealing element that helps hold against the stuffing box. And as the packing gland is tightened against the stuffing box, the compression packing between the two creates a seal for the leakage, right? So what we're trying to do here is avoid leakage, right? So that's why sometimes, if I over tight it, I'm gonna be okay, but that might not be the case, right? So the packing gland, it can be adjustable, so we can just untighten it a little bit more so we can decrease the stroke time, right? That's something that we will want to do. We will want to decrease the stroke time. If we increase the stroke time, we know that we have an issue with the packing gland, that it might be too tight. Now we have another thing that we have here is the back seat of a manual valve. So the back seat is this seating arrangement inside the bonnet. So this is gonna be the back seat. So it's gonna be the bonnet. So I think I have another picture. So this is the bonnet. So inside the bonnet, we're gonna have this inside the bonnet. So this back seat, it helps us on removing pressure from the packing with the stuffing, right? So it helps us release pressure from here. And it also isolates the leak in case that there's a leak, it helps us isolate it. So the back seat is gonna provide us like with this seal, right, between the stem and the bonnet, and it's gonna prevent the system pressure from building against the valve packing when the valve is fully open. And we usually have the back seats are often applied in gate and globe valves. So the back seat shall only be used to isolate the gland packing from the line medium. For example, when the gland packing leakage is evident and until the valve can be depressurized and repaired. That's when we should be using them. And finally, we have the inner lock. So the inner lock is gonna prevent two sources to be interconnected. For instance, if I am operating this MOV, this motor operated valve, the interlock, what it's gonna do is gonna say, okay, I don't want you to use this MOV, right? Let's close this one because I'm operating this one, or vice versa, right? If I'm operating this one, I'm closing this one. So it allows only one source, right, to be connected to the pump directly. And that's all that I have for Knowledge 5. Thank you so much.